G'day guys, today we're going over a scholarship question, another scholarship calculus question. So this is given that f of x equals this function here, we need to find the values a and b, and we're told that the f dash dash x function exists. Okay, that means that at 0, how should I do this? I'll draw a thing. At 0, so along this middle line, the y-axis, at x equals 0, the function should be differentiable because f dash dash x exists. And for it to be differentiable, we need to have a clean line like that. Even though there's a swap over between the functions here, it needs to have the same gradient and the same position at that point right there. So if we take, so we'll get into it now. So if we take x squared plus ax plus b, and we make that equal to e to the x plus sine x at x equals 0, which is what it should be if it's going to be f dash x is going to exist. So we're going to get 0 plus 0 plus b equals, so the x just made, when 0 equals x, they're just going to cancel or go to 0, sorry. E to the 0 plus sine of 0. And if you know what e to the 0 is, well, it's anything to the 0 is 1, and sine of 0 is 0. If we look at the sine function like this, sine function goes like this. So it's at 0, 0, 0. Right there. Okay, so this equals, so b equals 1. We've figured out one thing. Next one, so we've figured out that the same position, we've made them the same position. Now we need to make them the same gradient. So if we take the gradient function of both, so we're going to have 2x plus a equals e to the x plus cos of x then we're going to simply substitute x equals 0 again, because they've got to have the same gradient when x equals 0. So it's going to be, well, that's 0 plus a equals, well, e to the 0 is 1 again. And cos, if we look at our cos function, cos starts up here and goes down like this. So cos is going to equal 1 when x equals 0. So plus 1. So a equals 2. And I think that's basically all there is to it. So if we've solved for a, we've solved for b. So if we put this into our equation, we'd get x squared plus 2x plus 1. So that would give us some sort of parabola coming down to, so this is our second function. Our second function, I don't know what that would look like. We're just going to go like this. And so our parabola comes down and it has the exact same gradient at that point and the exact same position. That's a terrible parabola. Sweet as.